So what's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering topics, and sometimes I build things. Sometimes, but not today. Today's episode is actually another episode of Good, Better, Best, our whiteboarding series here on this channel, in which I teach you guys how to solve whiteboarding problems in a way that's super easy and it's simple for you to follow along. Today's video is actually going to be all about arrays. And I know you're thinking, you already made a video about arrays, but there's tons of array questions, so there must be more videos. So, as always, the timestamps are going to be in the description box below. Use them at your own discretion, and let's get into it. So we're going to be solving two questions today. The first being how to determine if there is a pair of numbers within the array that will return a given sum. So let me give you an example so this makes a little bit more sense. Say you have an array of numbers 1 through 10, and the sum that is given is 5. Within 1 through 10, you have 3 and 2, which when added together will give you 5. How do you find the location of 3 and 2? The second question that we're going to be solving is how to find the kth largest element within an array. So for example, let's say you have the same numbers 1 through 10, and we want to find the second largest element within the array. That would be 2. How do we find it? So let's get into our first solution. I'm going to call this solution 2 pointers. The very first thing that we're going to do is sort the array. How you choose to sort the array is completely up to you, but know that it is imperative for this solution to actually work. The second step that we're actually going to do is to create 2 pointers, a left pointer and a right pointer. The left pointer is going to start at the beginning of the array. The right pointer is going to start at the end of the array. The third step is to actually create a for loop that is going to loop over the length of the entire array. Inside of each iteration, we are going to create a temporary sum, which is the sum of the left pointer and the right pointer. If in the case the sum of the left pointer and the right pointer is the same as the sum that we are looking for, we will return the location of the left pointer and the right pointer. If this is not the case, we will compare the temporary sum to the given sum. If the temporary sum is greater than the given sum, we move the right pointer. If the temporary sum is less than the given sum, we move the left pointer. And this is the entire logic behind solution 1. So this is our first solution called 2 pointers. Right now, I'm simply writing some boilerplate code such as the name of the function and the return value and the input parameters. So the first thing we need to do, like I said before, is actually sort the array. I'm actually just going to use the arrays.sort method. The next thing we need to do is create the left pointer and the right pointer. The left pointer is going to be set to 0. The right pointer is going to be set to the length of the array minus 1. We're going to create a while loop, and our terminating condition is that our left pointer must be less than our right pointer. What we're going to do inside of this while loop is at every iteration, compare the array index value of the left plus the array index value of the right to the given sum. If it is equal to the sum that we're looking for, we're going to return the 2 indices. If in the case that the left array value and the right array value is smaller than the given sum, we're going to move the left pointer inward because the next number is larger. If the array value of the left pointer and the array value of the right pointer, if that sum is greater than the given sum, then we're going to move the right pointer inward. Because we sorted the array, the next number is actually smaller. Now I'm going to create an array called test array, and I'm going to fill it in with some random numbers. So now we're going to test our solution by calling our solution by name and giving it a sum. So I'm going to call test array, and I'm going to give it the sum value of 9. We should expect to return the indices 0 and 4. However, we do not. So it may seem like our solution did not work. However, we must remember that we actually sorted the array. So what I'm going to do here is actually show you the newly sorted array so we can double check to make sure our solution is accurate. The runtime of this solution will actually be O of n, regardless of what method of sorting that you use, such as merge sort or bubble sort. In the worst case, you would still have to iterate over the entire array just to determine that the pair was not there. Therefore, the runtime is n. Solution 2 is actually called the brute force method, and it's called this because you try every possible combination to see if the pair exists within the array. This is a very simple method to create. We're going to create it using 2 for loops. The outer for loop will start at 0 and iterate over the entire length of the array. The inner for loop will start at 1 and iterate over what's left of the array. At each iteration, we are going to compare the array index value of the outer loop plus the array index value of the inner loop to the given sum. If they are the same, then we will return the index of the outer loop and the index of the inner loop. If not, then we'll continue to iterate until a pair is found. So our next solution is called brute force, and as always, I am writing boilerplate code such as the name, the return type, and the parameters. For this solution, I'm going to create 2 for loops. The first for loop is going to start at 0, terminate at the length of the array, and increment by 1. The second for loop is going to start at 1, terminate at the array's end, and increment by 1. So we're going to check inside of our second for loop if the array value of I plus the array value of k is equal to sum. Here I am being lazy and copying the printout statement from before and changing it to work with the new method we're writing. And now we're going to test our solution. The runtime of this solution is actually n squared, and this is not an ideal solution to this problem. Because you're trying every single possible combination, that this solution can get to be very slow if you have a large amount of data. Our third solution is called mapping, and this is because we're going to use a hash map to help us solve this problem. If you're not familiar with hash maps, just think of hash maps as a key and value paired, meaning if you provide the hash map with a key, it will provide you with a value. A real-world example of this would be your ATM PIN number and your bank account information. Once you supply an ATM with your PIN number, it will supply you with your bank account information. How we're going to use this to our advantage is our keys are actually going to be a value that we will derive in the problem, and the value will actually be the index that we are currently on in the for loop. So the next step is we actually have to create a for loop that's going to iterate over the entire array. And at each iteration, we're going to create a temporary value called difference. This difference is going to hold the difference between sum and the current index value. So what we're going to do is we're going to check to see if difference is within our hash map. Difference is going to be the key value in our hash map, and the index is going to be the value within our hash map. So we're checking to see if difference is already within the hash map. If it is not within the hash map, we are going to add it to the hash map with the key being difference and the value being the index. As we iterate through the array, if we find that difference is already within the hash map, that means that there's another value within our array that will return the given sum. In order to get that, we must provide the difference and we will get the index value. This is how hash maps work. This one might be a little bit funky with me just explaining, so let's actually look at the code and it'll be a little bit easier for you to see. Our third solution is the mapping solution. And right now, as always, I'm writing boilerplate code, I'm writing the name of the function, and I'm writing the parameters that the function needs. The first thing I'm going to do is create a hash map. And then I'm going to import the hash map class. After that, I'm going to create that temporary difference value we talked about earlier. And now I'm creating a for loop to help us iterate over the entire array. It's going to start at 0, terminate at the array's end, and increment by 1. So once again, the logic I talked about earlier, if we provide this hash map with the correct key, it should provide us with the correct value. Once again, I'm going to be lazy and copy the return statement from earlier. Except for this one's going to be a little bit different. To access that actual value, we're going to need to provide the hash map with the key, which in this case is temp. Now I'm just printing out the array again, so it's a little bit easy to keep track. And here, if the key is not present within the hash map, add it to the hash map. And once again, we're going to test our code on the same test array. Looks like it works. So the runtime of this solution in worst case scenario is n, and this is if you have to traverse the entire array. In my opinion, this is the best solution for this problem because it's very easy to modify this code to return more than one pair. Let's say, for example, your array had duplicates. Let's say you have an array with the values 1, 1, 3, and 5, and you're asked to return a pair with a value of 4. With the way that our code is currently written, it would return 0 and 2. However, 1 and 2 would also be a valid solution to this problem. Our current code is very easy to modify, making this the superior solution, in my opinion. What's up guys, it's Taylor from post-production. In this next section, I say kth largest and kth smallest interchangeably, and that's really confusing. But I just want to let you guys know that kth smallest and kth largest are actually the same number. Let me give you a little quick example. Let's say you have the array 1, 2, and 3. The second smallest element in there is actually 2. Because 1 is the first smallest element. If I asked you to return the second largest element, it would also be 2, because 3 is the first largest element. Our second problem is to find the kth smallest element within an array. So let's say k is 2. How do you find the second smallest element? Let's say k is 18. How do you find the 18th smallest element within an array? This problem can seem very intimidating at the beginning, but the solution is dead simple. All you have to do is sort the array, and once you've sorted the array, return the index value of the given number minus 1. You might be wondering, what? When you sort the array is now in order. If you're trying to find the 18th smallest element, it's not actually at array 18, it's at array 17.
Let me give you an example of this. Let's say you had the array -1, 7, 100, 29, and 3. And I asked you to return the second largest element. After you sort the array would read as -1, 3, 7, 29, and 100. The second largest element would be 3, and 3 would be at the first index.
For kth smallest element, we are, of course, going to write the same boilerplate code we write for all of our methods. So the first thing that we're going to do is sort the array. I'm a fan of arrays.sort. You can use whatever sort that you want to use. And then all we're simply going to do is return the array indice of the given number -1. And that's it. Super simple. So let's test this out. Inside, we're going to call the function kth smallest element, and then we're going to provide it with the element that we want to return. I want to return the second smallest element. Therefore, I should expect to get 3. And we did. Looks like it works. The runtime of this solution completely depends on the sort method that you decide to use. For example, if you were to use bubble sort, your runtime would be O of n squared. If you were to use merge sort, it would be O of n log n. And just like that, we solved 2 questions: how to find 2 paired values within an array that will return a given sum, and how to find the kth smallest element within an array. Super simple. I hope you learned a lot, and I hope everything was very clear. If you have any questions, or you came up with an alternative solution, or you just want to talk, go ahead and, go wild in the comments. I'd be more than happy to read them. Bye. Well, I feel like you must have liked the video because you're still here. And if that's the case, you're in luck, because this is an entire series here on this channel. And you can just go and watch the next video right now if you want to. Or you could subscribe, that too. Or you could do both. You could subscribe and you can watch the next video. It's your choice, I'm not.